Alright, before break we were talking about similar polygons and the relationships between their perimeters and their areas. So we're going to review that a little bit. Okay. If you recall, the ratio of the perimeter is the same as the ratio of the sides. And the ratio of the sides is the flip of the scale factor. So if you have two rectangles here that are similar, find the scale factor and the ratio of the perimeters. So the scale factor is new over old, 24 over 16, which reduces to 3 to 2 right here. And you can check that because first shape times scale factor equals second shape. So does 10 times 3 over 2 equal 15? Yes. Scale factor greater than 1 means we're enlarging, and scale factor less than 1 means we're decreasing. The ratio of the sides is the flipped version of the scale factor. It's 16 to 24. Now we can do that as colons if you'd rather. So it could be like 16 to 24. If you prefer that format, it's totally fine. And that reduces to 2 to 3. We have enough information to calculate the perimeters here. The perimeter of the small is 10 plus 10 plus 16 plus 16, which is 52. The perimeter of the large is 15 plus 15 plus 24 plus 24, so it's 78. So the ratio of the perimeters is 52 to 78, which simplifies to 2 to 3. So the ratio of the sides and the ratio of the perimeters are the same, which makes sense because perimeters are just a bunch of sides added together. For example 2, using those same rectangles, find the ratio of the areas and verify that it fits the area theorem, which just means we're squaring things. So the area of the small one is 10 times 16, which is 160 units squared, and the area of the large one is 360 units squared. So we're putting those in ratio form. 160 to 360 simplifies to 4 to 9, and that is the squared version of 2 to 3. Okay, so you just square both the 2, you get 4, you square the 3, and you get 9. So that's the ratio of your areas. For example 3, find the ratio of the areas of the rhombi below. The two rhombi are similar. So now this 3 is just halfway across this diagonal, and this 5 is only halfway across the diagonal. The 6 is in the middle of the side, so it's both, or it's the whole side. And the 10 is the whole side. So we're going to find the ratio of this. If we want the ratio of the areas, we're going to find the ratio of the sides first, and then we're going to square it. The ratio of the sides is 6 to 10, which we reduce to 3 to 5. Square that, and you get 9 to 25. So the ratio of the areas is 9 to 25. So if you knew that the ratio of this guy, the first rhombus, was 18, then the ratio of, or the area of the second rhombus would be 50. For example 4, we have two similar trapezoids. The scale factor is 4/3. That means we're enlarging this trapezoid. If the area of the small trapezoid is 81, what's the area of the large trapezoid? Alright, so the ratio of the areas is 3/4 squared. Notice that this is the flipped version of 4/3. Ratio is the flipped version of the scale factor. So the ratio of the areas is 9 to 16. So 9 goes with the small one, 16 goes with the big one. 9 goes with 81, because 81 was the small trap. So we have this cross multiplication happening here. 9 goes to 81, 16 goes to the unknown area, cross multiply, 9a equals 1296. Divide both sides by 9. So the area of the large trapezoid is going to be 144. Two similar triangles. The ratio of the areas is 25 to 24. What is the scale factor? Okay, so remember scale factor and ratios are flipped. So I flipped that upside down, made it 64 to 25, and then we're square rooting it because sides to area is squared. So the ratio of the ratio of the sides would be 5 to 8. I need to fix it. This is supposed to be 8 to 5. And hopefully I'll have that fixed before you get this. The ratio of the sides is 8 to 5. the top shape. Top number is the first shape, bottom number is the second shape. So we're getting smaller. No, we're getting bigger. We're going from 25 to 64. I'm confusing myself. So the scale factor should be larger than 1. Okay, last example, and then you're going to do the rest on your own, and we'll talk about it during the meet. Use the ratios from example 5. Okay, so we're using the same ratios from example 5. Find the length and the base of the smaller triangle. The length of the base of the larger triangle is 24. Alright, I gotta do some shapes here. So we got small, we got big. Our scale factor is 8 to 5. So that means this guy has like a side of 5 and this side has a side of 8. Let's see. Find the base of the small triangle if the length of the base of our triangle is 24. Okay, so we know we're going in a ratio of 5 to 8, so that's where this comes from. And then we're trying to find the base to 24. So 5 and base are both on the small triangle, 8 and 24 are both on the large triangle, and then we can cross multiply. 8b equals 5 times 24. Okay, so again, the rest of this is going to be on your own. Please come to the meet with questions, and I will see you then.